Welcome to this episode of Mentors at Your Benchside, the podcast giving you advice, tips, and tools for getting the most out of your research. I'm Zandi Lenare, and today I'll be talking to you about why we run SDS-PAGE gels vertically. SDS-PAGE gels are a bit tricky to put together. Make the resolving gel, pour, add the isopropanol, wait, wipe the isopropanol away, make the stacking gel, pour, wait. Wow. Besides, if you don't get the seal just right, the unpolymerized gel leaks and then you have to start all over again. But hang on, why is SDS-PAGE run vertically anyway? It'd be way simpler to have a horizontal SDS-PAGE system. After all, agarose gel electrophoresis runs horizontally and gels never leak or tear. But how different are they really, and why is SDS-PAGE run vertically? I'll answer those burning questions in this nifty article and then, for fun, play devil's advocate and consider some suggestions left in the comments section. So why is SDS-PAGE run vertically? Of course, life would be much simpler with a horizontal SDS-PAGE system, but there are 3 excellent reasons why it has to be vertical. Answer 1. SDS-PAGE gels are discontinuous. As you well know from hours spent pouring them, SDS-PAGE gels are 2-component gels. They comprise a stacking gel and a resolving gel. A vertical arrangement allows you to make them sequentially. You pour the resolving gel first, and once it is set, pour the stacking gel on top of it. This results in one contiguous gel. It would be difficult, if not impossible, to prepare such a gel horizontally. Answer 2. Polymerization is inhibited by oxygen. Stop! Before you run down the patent office, clutching technical drawings of brilliant new casting apparatus on the back of a beer mat, consider this. Oxygen inhibits the polymerization of SDS-PAGE gels. Specifically, ammonium persulfate, or APS, in the SDS-PAGE gel mixture reacts with TEMID to produce sulfate-free radicals. These free radicals react with the acrylamide molecules in the presence of TEMID to initiate polymerization. Molecular oxygen in the atmosphere reacts with sulfate-free radicals, however. And if there are no sulfate-free radicals available to initiate acrylamide polymerization, there's no gel, just the unset mixture of ingredients. Sandwiching the gel mixture between 2 glass sandwich plates in isopropanol or a comb protects it from these pesky oxygen molecules. A horizontal system would inevitably be exposed to the atmosphere and the polymerization reaction wouldn't proceed efficiently, or be extremely difficult to pour with a straight interface between the resolving and stacking gels. So it looks like Biorad will keep the SDS-PAGE gel casting market cornered for now. Answer 3. A vertical system is cheaper. Money always finds a way to have some influence. The reagents used in SDS-PAGE gels are relatively expensive, so it wouldn't be cost-effective to pour them like agarose gels because you'd need much thicker gels to accommodate your sample analytes. It's more cost-effective to make thinner gels with tall but thin sample wells, and this is redoubled if you take a moment to consider how many SDS-PAGE gels a busy lab can get through. So what's the difference between agarose and polyacrylamide gels? I won't waste your time and labor any points here. Here are their key differences. Polyacrylamide gels polymerize, agarose gels set. Agarose gels contain a fluorescent dye. Polyacrylamide gels do not. Polyacrylamide gels are discontinuous. Agarose gels are continuous. Agarose gels may be rerun. Polyacrylamide gels may not. Polyacrylamide gels separate a narrower range of analytes. Agarose gels don't contain any toxic ingredients. Let's discuss some ideas for why SDS-PAGE is run vertically, for argument's sake. The question, why is SDS-PAGE run vertically, is not uncommon, because a few fun suggestions have been left in the comments section since this article was published, and here at Benchside Bio, we love to engage with our readers. Let's consider these suggestions and whether or not they could work in practice. The first suggestion is, what about precast gels? Unfortunately, you can't buy horizontal precast SDS-PAGE gels, and even if you could, there's no gel tank in the market in which you could run it. Another commenter asked, could you not pour a gel and move it horizontally after it's set? Definitely. You could load an SDS-PAGE gel that you've cast following a standard protocol and then flip it horizontally, and there's nothing to stop you from placing the gel, sandwiched between the glass plates, into an agarose gel electrophoresis tank and run it horizontally. But you've not really saved yourself any hassle by doing this, so what's the point? You've still cast and loaded the gel vertically. And I've never run an SDS-PAGE gel in an agro's tank, nor do I know anybody who's tried, so I can't say whether it would work or not. Plus, whilst I bet you could load the sample onto a horizontal SDS-PAGE gel using those bendy gel loading tips, what's to stop your sample from spilling out? It might be the case that 0.75 millimeter thick gels can retain your sample by surface tension alone when horizontal, but thicker gels would almost certainly leak. Don't forget too that the anode running buffer needs to have a single point of contact with the cathode running buffer. This is why we use a buffer dam when running one gel and is what causes the analytes to migrate downwards. For similar reasons, horizontal gels almost certainly wouldn't work for tris tricene SDS-PAGE because the anode and the cathode buffers must be kept separate and have a different composition. Someone else commented that having the gel vertical requires more buffer. It certainly does, but as the commenter correctly pointed out, the SDS-PAGE running buffer is cheap. It may also be reused several times. Given the compelling answers that we've just presented to the question, why is SDS-PAGE run vertically, saving money on running buffer is not enough reason to change the incumbent vertical system. A note from one of our readers. Since this article was republished, a reader contacted the Benchside Bio team to clue us in on a legacy SDS-PAGE system that did run horizontal gels. It was called FAST system. You can find a link to the user manual in the episode notes. There's even a picture of a stained gel that was run horizontally. Apparently the method used super thin gels, which sped up running, blotting, and probing. It doesn't look like it's available anymore, although one of our team did find one for sale on a well-known auction site. Bad news for anyone who wanted to try running horizontal SDS-PAGE gels. Good news for us, because we don't have to take the article down. Thank you, reader. And now you know. The next time someone asks, why is SDS-PAGE run vertically, you can give a cogent answer. Thank you for the comments. They've been fun to consider. Please feel free to chime in with your own suggestions, serious or not. It's good fun. Be sure to let us know if you found this article helpful too. And finally, be sure to check out some other great resources on SDS-PAGE here on Benchside Bio. You can learn the difference between setting constant current or voltage, or get right back into the basics and learn how SDS-PAGE works. So that's it for why we run SDS-PAGE vertically. Check out the episode description for links to related articles and resources. And don't forget to subscribe to the podcast to get more help and advice from mentors at your benchside.